In this class, we're going to consider the product rule for differentiation. So as the name suggests, this is the rule we use when we're trying to differentiate a function which is the product, in other words, the multiple of two other functions. So the format that we're kind of dealing with here is when we're trying to take the derivative, so let's say the derivative with respect to x of the product of two functions, say f and g. So f of x times g of x. Now, in reality, you're not going to be presented with two separate functions sitting next to each other in the sense of one being, hey, this is f of x and this is g of x. You're just going to see things like this where you've got functions written in their kind of algebraic form. So this would be your f function here, and this would be your g function, and again this would be your f, and this is your g, and then your f and your g. This term is not a term that needs the product rule, because it's not a product of functions, it's just in the format to use the power rule. So we're looking for basically the format where you've got two functions multiplying together. That then tells us, hey, we can't use the normal power rule, we've got to use the product rule. Now, intuitively, you might think that the derivative of a product is going to be equal to the product of the derivatives. In other words, take the derivative of f, take the derivative of g, and then multiply those two derivatives together. It doesn't quite actually work like that. The way that it works is the derivative of this product is equal to the derivative of one function times the other function plus the derivative of the other function times the first function. Or in words, or in that's in words, in algebra, it would be f prime of x times g of x plus g prime of x times f of x. Now, there's different ways to write this, and you can switch around the order because it's a plus. Because remember, when we're doing addition, the order doesn't actually matter. So sometimes you'll see it written more maybe as f of x and then g prime of x and then g of x and then f prime of x. If you try and learn it formulaically, that's fine if you remember the formula, but the important thing is whether you use this version, which is probably more the textbook version actually, or this one, as long as you've got the derivative of both functions, so here is g prime and here's f prime, multiplying to the other function. So as long as I've got my g prime and it's multiplying to f, and my f prime and it's multiplying to g, and multiplying those and adding them together, it doesn't really matter on the order. So don't get too hung up on making sure they're all in the perfect place. Yeah, sure, if you want to be consistent and use the same formula every time, that's fine. There might just be scenarios where maybe the algebra makes it such that you want to switch around the order. Maybe. I would say try and be a little flexible in it, but essentially it's just the derivative of one function times the other, plus the derivative of the other function times the first function. And maybe it's better demonstrated by example. But the important thing is it's not equal to just f prime of x multiplied to g prime of x. It does not equal that, which is what everyone intuitively would say that it maybe could equal. Okay, so let's look at how we're going to apply this product rule to these guys here. The first thing is just to ask yourself, do I need to use the product rule? That is obviously the criteria. There's a whole bunch of different rules you're going to be learning in Calculus 1, and part of the challenge is being able to separate out which rule is applicable to which scenario. So here we've got basically a function, the function 2x squared plus 4x. That's a quadratic function. Here we've got a sort of linear function 5 plus 3x. They are multiplying together because the brackets imply multiplication. So certainly we can use the product rule here. We could also just multiply out the brackets and make a polynomial and then just use the power rule on the polynomial. Sometimes that is a better option actually. And in fact, in this case, it's probably a similar level of work to do this question. Either way, you'll get the same result. So just use your own judgment with this type of scenario. There are other scenarios like these two here where you've got no choice but to use the product rule. So we're going to go ahead and use the product rule for this one. So let's say that we're going to use this version here, which would say take the first function and just kind of leave it as it is. So it'll be 2x squared plus 4x. And we're going to multiply that to the derivative of the second function. The derivative of this we can get using the power rule. The derivative of 5 is just 0, so that disappears. The derivative of 3x is just 3. So we're going to be multiplying this to 3. So you could squeeze that in there, or maybe just use a bracket and put it on the end like that. Ideally, maybe you'd want that in front, but you don't know at the time that you're taking that second derivative that it is just going to be a number. Sometimes, usually, it's probably going to be more than a number, like an x term. So you'll just use a bracket and then another bracket to imply the multiplication, which we're getting basically from this part here. Okay, and then we're just going to add to that the derivative of the first function times the second function. So the derivative of this guy here, again, we can use the power rule for. Both of these terms have got a non-zero derivative. So the first term differentiates to 4x using the power rule. Second term differentiates to 4, just the number 4, and then we're multiplying that to the other function. So multiply to 5 plus 3x. Okay, so we would carry on with this one and tidy it up a little. So let's just go ahead and multiply the bracket. So we're multiplying 3 into this bracket to give us 6x squared plus 12x, and then multiplying these together using FOIL or whatever technique you use. So we're going to get a 20 x term. We're going to get a 12, we're going to get a 20x term, and we're going to get a 12x squared, and we're going to get a 20, just the number 20, and then a 12x. So we can just gather together all our terms. So we've got a 12 and a 6x squared, so it's going to give us 18x squared. So we're not really doing, well, we're not doing differentiation at this point. We've taken our derivative, we're just tidying up, which is quite common actually, certainly in the product rule, because you often end up with quite a big mess of algebra that you need to tidy up. So gathering together our x terms, we've got 12 and 20 is 32, plus another 12 is 44. So we get 44x, and then our only number term is a 20, so it's plus 20. So it comes out to be this sort of trinomial, this quadratic form. Now again, if we did multiply out the brackets, we would just get the same result anyway. And we'll just leave that. We'll just trust that the product rule has worked in that case. Okay, so let's move over to the next example. In fact, I'm just going to pull this one down here to make a little space. So f of x equals x cos x. That's in the perfect format to use the product rule. We've got the functions x and cos x. Now, at this point, you may not know how to differentiate the trig functions. So what I might do actually is just quickly put those up here. They're very, very straightforward. We're actually going to deal with those in another class, but because quite often you'll see with the product rule a trig function, I just wanted to include some trig functions here, even though you might not yet be sure how to differentiate them. But basically, when we differentiate cosine, the derivative of cosine x is, I'll just draw it like this, is negative sine x, and the derivative of sine x is positive cosine x. So they're very, very straightforward. They basically just turn into each other, and one of them's got the negative. So we're going to go straight into taking our derivative here. Okay, so again, we'll probably use kind of this format, which says just leave your first function alone. So the first function here is just x, and then we're going to multiply that to the derivative of cosine x. The derivative of cosine x is negative sine x, so we use a bracket. Negative sine x, and we're going to add to that the derivative of the second function times the derivative of the first. So the second function is cosine x. The derivative of the first function, which is the derivative of x, is just 1. So that's going to multiply to 1, so we don't really need in this case to put that in there. So we've got all of our terms. This would be a 1 in here, but we can just drop that. And there's nothing really more we can do with this one in terms of like combining terms like we did up here. All we could do, these are going to multiply together to give you a negative term. This is a positive term, so we could spin those around just to neaten up the algebra. And we're going to get cos x. These guys would form together because they're a product, and it would be minus x sine x. Okay, so These with the sine and cosine can come out, in fact with the product rule in general, but particularly with these, they can come out to be quite odd looking results in some ways, but yeah, that there basically is a derivative of that product. Fairly common to see a similar scenario to this, maybe sometimes with like an x squared in here or a cos 2x or something like that, but you'll see those as you move forward with calculus. Okay, cool, right, so we're done with this one. Let's move on and have a go at this guy here. So again, asking ourselves the question, do we need to use the product rule? You know, don't use a rule that you don't have to use if you can get away with using an easier rule. But this here is clearly a product. It's a product of the function x cubed with the function sine x. So we definitely do have to use the product rule. We can't like multiply out brackets or anything to make it into a power rule type question. But this term on the end does need the power rule. And that highlights the point that you can use multiple rules within taking one derivative. You don't have to say, I'm using the power rule for everything or the product rule for everything. You just use whatever rule is applicable to that term. So this term needs a product rule. So I'm just going to move this over to make some space. So we can go straight into using the product rule this time. Okay, so we're going to take the derivative of the second function and multiply it to the first. So the first function is just x cubed. Derivative of sine is cosine x using our rule from up here. And then it's going to be adding that to the derivative of the first function, which is 3x squared, times the second function, which is just sine x. And I got the 3x squared just using the power rule on the x cubed term. And then this term 2x to the minus 4 is in the perfect format to use the power rule. So that would become minus 8x to the minus 5, okay? So I'm assuming that you're familiar already with the power rule if you're using the product rule. Okay, so again, like this one over here, there's not much we can do in terms of combining terms. There's nothing really much we can do. We can just maybe take that out of the brackets and sort of neaten it up a little. So we're going to write that as x cubed cos x plus 3x squared sine x. And then the term on the end is already a minus, so we don't even need to spin around the order or anything. We'll just leave that as a minus 8x to the minus 5 on the end. So that's quite a good example to highlight using multiple rules within one question. So product rule, very common. You'll use it in quite a lot of different scenarios. I would say kind of develop your own style. Like this textbook style doesn't sit very well with me personally. I prefer to use it this way. And I remember this as the derivative of the first times the second plus the derivative of the second times the first. There's a whole bunch of little acronyms out there to help you remember how to do it. You might find that you've just got your own personal preference. So whatever way you're comfortable with is fine. That's why I've shown you a couple of variations. Well, the only variations really doesn't really matter on the order because it's a plus. So as long as you get the derivative of both the functions multiplying to the other function and add all that together, then that's absolutely fine. The main challenge will be remembering that rule exists, because you're going to see expressions where, okay, if you're working a set of questions and they're all on the product rule, then you know to use the product rule. It's a no-brainer. But if you're working, say, a mixed exercise or on a test or an exam, and you've got a question where you're asked to differentiate, it's very easy to get your rules muddled because you're going to be learning more rules. But just remember that the definition of using the product rule comes down to finding the product of functions, which sometimes can be a little more subtle than you realize. Okay, so just gain enough experience using the rule to recognize the different scenarios in which you can use it. So hopefully that makes sense. Like the power rule, spend some time practicing this rule. You can't get very far in differential calculus without being really competent with actually using the rules, because later on you're going to apply these rules to different types of problem. So you don't want to actually have a stumbling block of just not being able to use a rule. You want to be quite confident with the rule so you can then apply it to different scenarios. So definitely spend a bit of time practicing this rule. In the next class, we're going to look at the next rule, which is the quotient rule. And that's when we've got a function divided by a function, and that requires another rule to add to your sort of list of techniques that you're going to be learning in Calculus 1.